welcome. Like Courtney was just saying, my name is Brien Blandford, and my role at AWS is to help our partners like Eagle Dream support our customers. So the way that we do this often is through addressing business issues first via the technology that we're deploying. And serverless computing and data lakes are two of the bigger trends inside tech right now that are very very much able to support a lot of different use cases and to really help businesses think about their business problem instead of thinking about what's going on behind the scenes for their IT stack. So if you're new to this, I'm going to explain what serverless computing means and how it's different than traditional computing. And then we're going to talk about data lakes and then how those two tie together. So first, why would we do this? Well, we all kind of know this, but data is an asset. It's the world's most valuable resource. There's more and more sources every day of data that are coming at us or coming to us. And oftentimes people don't know what to do with all of this data. So we need a place to put this, and we need to take actionable insights on it, as Courtney mentioned. But you can't just ignore this. Traditional industries that typically didn't look at data, even though they may have had that stream of data, are now relying on that data to better their business case. I've heard people say that every single company, no matter what you do, is a technology company. And then on top of that, you're a healthcare company, or you're a gaming company, or you're an exercise company. So you're, at the heart of the way the world is moving today, everyone has to be comfortable with data and comfortable bringing that into the fold of their business applications. And there's a lot more data than people think. It's growing exponentially. So we see that there are more sources, whether it's from social media feeds or chatbots or systems that we never thought could produce data. We're seeing more and more of this come. And it also has to live for a long time. So there's a scale to this that the world hasn't seen before that we couldn't focus on because it wasn't cheap enough or there weren't the platforms that could hold it. But as we start to see this, we have to prepare our businesses to handle this much data. And so just to give you kind of two examples of this, one is a born in the cloud company called Fortnite. You may have heard of them. They have at any given time 125 million players, and they needed a constant feedback loop to take data from many different people playing and provide them a better user experience. So this has to happen quick. So if you think about 125 million individual players producing a constant stream of data, that's quite a bit. How do you store this? How do you take insights on it? How do you do things fast, as well as historically look back and say, what did we do that worked and what did we do that didn't, and gain new insights from that? But it also affects more traditional companies. So I mentioned an exercise company because Equinox had a similar challenge. How do they make a better customer experience? You typically don't think of a gym as a place where data is very relevant, but then you start to peel back layers of that onion a little bit and really see that there's a lot of applications here that might be helping people further their exercise experience or kind of maintain their track along their goals. So you could have a Fitbit, you could have a treadmill, you could have some kind of weight machine that is sending data to the cloud that says, hey, this person has increased their strength. All of these different kinds of sources of data need to combine into a user experience that can allow Equinox to retain their users and grow their user base. So it's important for even industries where you might not have originally thought the data is going to be king, it's still going to be very apparent in the future. So how do we build these kinds of applications that can leverage this data, and what does it take to do that? When we start talking about data at scale, the paradigm shifts quite a bit. So doing things on a small scale and POCing things is great, but how do you take this into production? How do you make it reliable, and how do you make it cost effective? And this is where these two new patterns in tech are kind of merging. One is the data lake and the other is serverless. So let's talk about what serverless means. So this is an example of the CPU usage for Amazon.com. Our traffic in the month of November, it's got a very steady baseline, and then at the end of November, near Black Friday, we see a huge spike. We've introduced another spike in Prime Day in the middle of the year, but what this effectively meant is that we had to provision capacity to handle that spike. And that accounted for our actual traffic accounted for 24% of the capacity provisioned, and 76% was wasted. So if you're ever wondering how AWS became what it is today, it's because of this. We saw this huge amount of unused capacity that we had, and we thought, well, I bet there's a lot of other organizations that have something similar. What if we could share that extra capacity with others? And so this requires quite a bit of change to start thinking about not provisioning capacity for the peak. It doesn't just require architectural changes, it also requires operational changes. And kind of similar to George's presentation, it requires shifting that paradigm of how companies operate. And we have direct experience with this at Amazon. So in 2001, we had some very monolithic applications and monolithic databases. And we were still actually a pretty small company at that time, small in terms of compared to what we are today. And we knew that if we wanted to grow and scale the way that was known that we could, we had to break this up. But breaking up the technology is one thing, but we realized we also had to break up the teams. To do anything on this monolithic application required multiple teams to be engaged, 11, 12, 13 different teams. And it would take weeks just to figure out the game plan, much less start working on it. Having that many teams involved in one decision is just not sustainable, and it's not scalable. So what we decided to do was not only break apart our monolithic application, but we broke apart our teams. And we have this concept called a two pizza team, where no team at Amazon should be bigger than can be fed by two pizzas. And it's true. You see teams that start to get to 10 people and they'll split and they'll break up. And the reason for this is that one team, just like a microservice, should focus on one specific task. They should be really good at doing one thing and do it well. And other teams that need that task done for them can come to that team and say, I need this task done. So it's just the same as building out microservices, as building out these teams. Making sure that you decompose for agility is key for this kind of organizational change as well. And so the first step that you may take into going towards a serverless path is to look at what your peak is. And you may have provisioned 10% above that peak, but you can start with things like auto scaling. So this is kind of the more traditional way that the cloud has helped throughout the past, where you can provision an EC2 instance and add more instances to an auto scaling group to meet demand. And you can refine that. You can get more granular, use smaller instances, have a bigger cluster. You can even do other things to reduce your costs, such as buy reserved instances that handle your base load and then add dynamically on demand as you need. But there's a few issues here. One, you could have provisioned still capacity that you're not using. And so that's obviously not ideal. You could also have capacity that you need to provision dynamically, but you barely need it. And you don't need it for very long. So why are you provisioning another instance for that? And then you can have a pretty extreme spike in traffic that might be hard to handle, and make sure that your applications can scale quickly. So that's really where serverless comes in. With serverless, there's no infrastructure provisioning. There's nothing you have to manage under the hood. All you have to really do is bring your code. It automatically scales. And what that allows is for you to only pay for the compute you need to drive business value. So if you have a swell of customers, your costs are going to go up, but also your customer engagement is going up. So the business is gaining from that increase of compute. Whereas if you have a kind of low point in customer traffic, you're not paying for resources that aren't driving business value. These are also managed services for the most part, and they are built to be highly available and secure. So best architectural practices are built in for you under the hood. So this also changes your responsibility as a customer. In the past, when you had just EC2, AWS handled the hardware, software, networking in the facilities. We handled a lot of that kind of underlying heavy lift. But a lot of the compliance and a lot of the scaling and the provision and the management of that layer was still on the customers to take care of. Not only did you have to bring your code, you had to make sure that your underlying infrastructure worked. But as you move further up the stack into more and more serverless realms, both with AWS Fargate, which is a serverless service for container orchestration, as well as Lambda, which is kind of the pinnacle of serverless, where you just bring your code. You only have to bring the code, make sure that your code works and that it addresses your business problem, and all of the backend is handled for you. There's no more patching, there's no more orchestration, there's no more worrying about availability, no more worrying about scale. And there's a big spectrum of this. So it's not required that you go all in on serverless. You can pick apart pieces of this. And when I mentioned that Amazon.com switched from a monolith to microservices, the very first thing we did was create a service called SQS, Simple Queue Service. And that was needed to get these different teams to talk to each other programmatically. So queue those messages between what one team does and what another team does. And that was actually the first service that was built that became Amazon Web Services. The very next one that was built was S3. So officially when AWS launched, S3 was the first service. So if you take those two services, SQS and S3, the very first things AWS ever did were by their nature serverless. So it's something that has been around for a long time, but is now just becoming kind of a more of a hot topic. But there's other things in this mix that you can use as well. There's DynamoDB, which is a NoSQL key value pair database that's completely serverless. You don't think about the infrastructure, you just think about the data and your the way that you're using that data. There's even Aurora Serverless, which is a database engine that supports MySQL and PostgreSQL, as well as things like Fargate for containers or Kinesis for streaming data or acting as a messaging platform. So there's a big spectrum here of where you can start plugging in pieces of serverless into applications that may have already been existing. And so takeaway from this is that for when people talk about cloud native, what I think they were referring to is architectures that are small and loosely joined, so that you can quickly adapt, you can quickly innovate, and you can quickly scale out what you're doing. So when you build a microservice, think about how I'm going to deploy that, think about what it's supposed to accomplish, and think about how it's used by other services. Amazon.com uses thousands of individual microservices that are loosely joined together, and it works to orchestrate this entire platform. And so that gets us to data lakes. Having those kinds of compute analytics on top is great, but you need data to supply those often. So customers are really wanting to grow their data exponentially from various and heterogeneous sources, and that's becoming increasingly diverse. So you might not have thought about a new source of data 5 years ago that suddenly is very apparent today. Like nobody thought about ingesting Twitter feeds as a source of data to drive their user satisfaction scores. You also might have many teams that are requiring data that come from different perspectives. Some might be from sales, or some might be from logistics, and some might be machine learning data scientists. And these many different teams need the same data source, but they might need it in different formats. And you have lots of different applications that are going to be analyzing this data. So you need some kind of system to take in data, a high amount of data, store it durably, do it cheaply, and have that presented to people in various formats. And there's complications to traditional approaches to this where it was siloed. So a lot of times the way that this was handled is on write, you had to fit data to a schema. So when data came in from a machine or data came in from a human, it was converted to fit a very specific schema that works for a specific application. But that might not be the same paradigm for all the applications that your business could innovatively produce. So the implication is that we need a new method for this. Data can't be siloed and it can't be expensive, and we need to store that for the long term. And this is really where data lakes come in. We want to move to a single store. We want it securely stored in many different standard formats and grow with low costs and analyze the data in various ways. And so at the heart of a data lake, you can store exabytes of data. S3 is going to be the basis for our data lakes where everything comes in. And S3 has virtually no scale limit. We need to curate this data though when it lands. So we have all these different consumers of this data that need it in different formats. So we want to make this available in each stage and transform it on the fly. We also want to do this once. So we want to load it and catalog it once. Maybe this is to a relational schema. Maybe this is not a relational schema, but we need to transform this once and have it in a place that all of our teams can ingest it and make that data available to many tools. And so this really supports innovation through having all these different open formats. It unblocks a lot of the teams and lets people really start to innovate and try things when they may have been blocked by data availability before. And so from serverless perspective, how do we leverage a data lake? Well, streaming data can come in from many different devices and sensors, from different platforms, from traditional kinds of data stores. And we might need to stream that data in and identify the schema that data proposes when it lands. Then we can transform that data through various serverless tools that I'll mention in a following slide to build out what our formats are going to look like for the teams that are going to be consuming this data. And then we need to have a catalog so that ad hoc queries can be performed, so that our machine learning or AI teams can quickly identify data to fit a feature set, or analytics teams can process that data and find commonalities among customer databases, or send that data to a data warehouse where we can make business intelligence decisions looking through historic data and visualize that data quickly. And so a standard serverless architecture on top of a data lake would be something like this, where you can ingest via a service like Kinesis Firehose to provide a scalable ingestion platform for data from many different sources. Or it could come from IoT data, whether those are sensors or web clicks or social media. And all of that data can land in S3. Using AWS Glue, you can transform that data on the fly serverlessly and have data be transformed either to meet a certain format for a team, or be curated in a data mart for a team, so that they have access to the data they need, but not access to data they don't. And that helps build in security at the layer of just presenting to folks and to applications the data that is relevant to them. And then we might need to query that data via a tool like Athena, where we can perform SQL queries on data that has no structure defined, and present that data to either machine learning applications or visualize it with something like QuickSight. So this is an example workflow of how you can build a true serverless pipeline for data ingestion and data cleansing, and present it to teams and applications that then can build microservices on top of that to really leverage the data that you're consuming to provide business insights. So with that, what do you want to build today? Any questions that you have, I would love to answer about how you can leverage serverless in your business and how you can leverage data lakes.
Awesome. Thank you so much, Brien. I actually have a question while people put some things in the chat box or kind of think of how they want to ask. Have you seen, with kind of the current circumstances with COVID, there's been an increasing need or interest in serverless, or mainly serverless, not really data lakes? Have you seen anything like that with trends?
Yeah, so especially with COVID, organizations have had to respond really quickly to a total different paradigm. I just had a retail customer yesterday tell me that they deployed their first application on AWS, and it was to get 800 of their stores curbside pickup enabled. And they built that all serverlessly. So it was something where they didn't want to have to stand up any kind of infrastructure. They didn't know how relevant this would be if people were actually going to use this new service they were providing, but they did that in 2 days. So they were able to make a completely serverless way for their customers to engage with them in a paradigm they had never explored before. They were traditional brick and mortar across 800 stores across the US. So it's something that you could have done that in a traditional means on the cloud. It would have been very hard to do that in that time frame on-prem. But serverless really makes it something that is super cheap. You can turn it on, and if no one's using it, then you don't pay anything. If suddenly there's a huge demand, you're actually paying for that value that was derived.
Awesome. No, that's great. And then I know we saw a lot of interaction in the chat box around your pizza teams. Can you give a little insight or suggestions on how someone might get started implementing that methodology or that process with their own teams?
Sure. So if you think about it as a microservice, think of your teams as microservices. If you've ever started thinking through how to break up a monolith into a microservice application, it would be a similar paradigm. So let's take the technology first. Say that you had a storefront, like a retail site, and it's an e-commerce site. You're going to need a microservice that's going to check inventory for a product. You're going to need a microservice that's going to handle credit card payments. You're going to need a microservice that's going to handle the display of the initial website where that customer is going to land. All these different microservices are going to have to talk to each other. So when you think about that, they each are broken out to do one specific task. The credit card application and the credit card payment microservice really doesn't ever think about what that front end experience looks like for the customer. It's just handling that credit card processing. So think of your teams in the same way of what specific tasks are teams assigned to do today. And say you have a very large team doing many different tasks. Can you break them up into smaller pieces and allow them to focus on things that they, one, are really passionate about, or two, are really good at? And now you've got a team that focuses on that specific aspect that might interface with another team, and they're going to expose an API and say, this is what I do. This is what my team does. Here's the boundaries of what I do. if what you need meets the needs that I provide, then that's when you would ask me for some kind of requirement. That's kind of the way that we work in terms of AWS. We'll find like a great example of how that kind of natively happens is someone has an idea. They're on a solutions architecture team and they're like, oh, I see a lot of customers who are just getting started on AWS need a multi-account strategy. I'm going to build a solution for that. And boom, they do. There's traction. And suddenly a new team gets formed around that. And that's what that team does, is help customers build a multi-account strategy. And that's how the automated landing zone was built. That's how eventually a service called AWS Control Tower was built based on that single idea. That started with a single solution architect who then kind of progressed that out. And so a team kind of, it's almost like bubbles that kind of natively form and they grow. And then if they get too big, they pop into smaller bubbles. That's how it works in terms of Amazon and AWS specifically.
Awesome. Thank you so much, Brien. I really appreciate you taking the time to join us today for another Tech
Of course.
Talk.
Of course.